What if I told you that the Earth's magnetic field is collapsing right now? Would you believe me? Probably not. After all, every day we hear news of something apocalyptic happening and most of them end up being false alarms. But this time things are different. The Earth's magnetic field is indeed weakening and scientists are still struggling to understand why. And while it sounds scary, as far as we know, the Earth's magnetic field plays an essential role for all life on our planet. Without it, Earth would be a barren wasteland just like Mars. So how does it work? Why is it weakening and what will happen when it collapses? And finally, can we do anything about it? These are the questions we'll answer today. As I've mentioned before, the Earth's magnetic field is crucial for all life on the planet. It protects us from deadly cosmic radiation and helps regulate our climate. You see, our sun is constantly emitting a stream of charged particles called the solar wind. If the solar wind hits a planet directly, it strips away its atmosphere and leaves it lifeless. Just look at Mars. That's why the Earth's magnetic field is so important. It acts like an invisible shield that repels the solar wind. But wait, Earth doesn't have a magnetic core like the Sun. So where does the magnetic field come from? It all happens thanks to the movement of molten iron in the Earth's outer core. It's basically a giant dynamo. As the Earth rotates, the molten iron is dragged along by the planet's spin. This creates electric currents which in turn generate magnetic fields. They're similar to the magnetic fields you get around a wire that carries an electric current. Now here's the thing. The Earth's magnetic field isn't perfectly symmetrical. There are areas where the magnetic field lines converge and these areas are called magnetic poles. Now normally they're located near the geographic poles but sometimes they can wander and even flip. Most of the time they stay within a few hundred kilometers from the geographic poles but between 1900 and 1918, the magnetic North Pole shifted by almost 60 degrees and moved much closer to the geographic South Pole. This means that magnetic field lines converged almost on top of each other. This period is called the excursion and it was recorded in the sediments of the Pacific Ocean floor. Scientists analyzed the sediments using a special type of rock called a magnetostratigraphic marker. Basically, these are rocks that contain magnetic minerals that align themselves with the Earth's magnetic field. By studying the orientation of the mineral grains in these rocks, scientists can reconstruct the Earth's magnetic field and find out what happened in the past. For example, by analyzing the sediment layers, they found out that during the excursion, the magnetic North Pole migrated rapidly. It moved at an average speed of 17 kilometers per year, which is comparable to the speed of continental drift. Moreover, scientists found evidence of even faster shifts in the past. For example, about 800 million years ago, the magnetic North Pole moved 23 degrees in just 3 years. That's about 20 times faster than today. The problem is that while we know that such events took place in the past, we don't know what triggered them. Some scientists think that it was a supervolcano eruption. In the past, there were several volcanic eruptions that released an enormous amount of ash into the atmosphere. It could have disrupted the flow of molten iron in the Earth's core and caused the magnetic pole shift. But other scientists argue against this because the magnetic excursions seem to be too regular to be caused by random volcanic eruptions. What's even stranger is that we're due for another excursion. You see, the Earth's magnetic field already shows signs of destabilization. In 2005, scientists noticed that the magnetic North Pole started wandering much faster. It moved from Canada to Siberia in just 40 years. At some point, the North Pole will reach the South Pole and then our planet will have its first magnetic pole reversal. Magnetic pole reversals are nothing new for the Earth. They happened many times in the past, but they usually take hundreds of thousands of years. Today, however, it may happen much sooner. And while some people claim that it will bring about the end of the world, it's not entirely true. First of all, the magnetic poles won't literally flip. The Earth's rotation is so fast that both poles will complete many rotations before the magnetic field reorients itself. This will happen somewhere between 250 and 300,000 years from now. However, there will be a period of instability leading up to the pole reversal and during this time, the Earth's magnetic field will be weaker than usual. This will increase the influx of cosmic radiation and it will negatively affect our planet. It will cause more forest fires, disrupt the GPS and communication systems and mess up migratory birds' navigation. But I wouldn't worry too much about it. Even though we won't survive the pole reversal, humanity will likely survive. We'll probably migrate to other planets by that time. But you might wonder, how do we know that the Earth's magnetic field is actually weakening? Well, it all started back in 1859 when British physicist and geophysicist Edward Sabine noticed that the magnetic elements of the Earth's field are changing. In the early 1900s, they continued to drift apart and move toward the poles. Then in the late 1970s, they suddenly started moving back. Now the magnetic poles are only 11 degrees apart while they used to be 15 degrees apart. In fact, over the past 200 years, the magnetic North Pole has moved 40 degrees and the strength of the magnetic field has decreased by 10%. On top of that, there was also the so-called South Atlantic anomaly. In the early 1970s, satellites started reporting unusually high levels of radiation when passing over the South Atlantic anomaly. It's an area of disturbed magnetic fields where the Van Allen radiation belt is thinner than usual. Normally it protects Earth from harmful radiation, but inside the South Atlantic anomaly, satellites started malfunctioning. In 2005, the anomaly started expanding rapidly. In just a few years, its radius increased by 20%. And while scientists don't know exactly what caused this phenomenon, they think it's related to the magnetic field weakening. Another piece of evidence is the upper atmosphere. As I said before, the Earth's magnetic field protects us from cosmic radiation, but it also heats up the upper atmosphere. The energy comes from the solar wind, but it's channeled through the magnetic field lines and then it's deposited in the atmosphere. Since the Earth's magnetic field is weakening, less energy is transferred to the atmosphere, which means it should cool down. And that's exactly what's happening. Since 1971, the temperature in the ionosphere has decreased by 1 degree Celsius. And while that doesn't sound like much, it's actually 10 times more than the average decrease in global temperatures. So what causes the magnetic field to weaken? One of the popular theories is that it's due to the excess heat coming from the Earth's core. Deep inside the Earth, nuclear reactions occur and they release tremendous amounts of heat. Some of that heat comes out through volcanoes and geysers, but most of it is carried by convection currents in the mantle. These currents transport heat from the core to the surface where it's radiated into space. But recently, scientists found out that the heat flow from the Earth's core is about 50% higher than it should be. This means that something is heating up the Earth's interior and it weakens the magnetic field. But what could be the reason behind this? According to a paper published in Nature, Earth's magnetic field is being weakened by massive ancient viruses. They are called giant viruses and they have double-stranded DNA genomes that are much larger than those of typical viruses. In the past, they were thought to be bacteria or even single-celled organisms. But in 2003, scientists discovered that they're actually viruses. These viruses are currently inactive, but millions of years ago, they infected the ancestors of modern humans and other animals. Some of them are still present in our DNA and they're called endogenous viral elements. When scientists extracted the DNA of endogenous viral elements from the Earth's core, they found that it produces a magnetic signal very similar to that of hematite. Hematite is an iron oxide that's weakly magnetic. But the presence of viruses doesn't explain why the Earth's magnetic field is weakening. Turns out that when the double-stranded DNA of viruses gets heated, it starts to decompose and release iron ions. These ions gather around the magnetic field lines and reduce their strength. In fact, scientists have managed to reproduce this effect in the laboratory. They heated the DNA of giant viruses to 60 degrees Celsius and found that it started releasing iron ions. It's possible that something similar is happening inside the Earth's core, although no one knows exactly what's causing the extra heat. Perhaps the Earth's core is reacting to the giant viruses in the same way. If that's the case, we're unlikely to find a solution to the problem anytime soon. The only way to confirm this theory is to drill deep into the Earth's core and collect samples. But drilling a hole that deep is virtually impossible. The deepest hole we've ever dug is called the Colima Super Deep Borehole and it reaches a depth of 12 kilometers below the Earth's surface. That's why the Earth's magnetic field will remain a mystery for a long time. Who knows? Maybe one day we'll find out that the whole planet is actually one giant living organism and its magnetic field is just a side effect of its metabolism. And thank you for watching.